Okay, we're live. Anyway, let me show you what to do on Lab 3.3. Lab 3.3, this is the throw-up lab. Here's what you have to do. It's very simple. You're going to make basically 3 sketches and label the sketches, or 4 sketches, label the sketches. 1 sketch is for low, 1 sketch is for medium, 1 sketch is for high. If you don't have super, well, I guess if you did super, we can make that one bonus. All right, so all you're going to do, what's the matter? All right, now, all you're going to do is just sketch what the rocket's going to do. So the rocket begins, you can put a little arrow over here, the rocket begins upward, pointing and launching upward. So you can put a blinking light diagram. Blink. You can put the other blink up here, about, let's say, here, 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 here. It doesn't have to be a particularly fancy diagram. Cross that one out. Then, what does it do on the way down? Same spots, right? So you can circle them here, 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 and then here, put a little arrow on the way down. Of course, ours did not quite do that. I wish they had. We would have a full set of them still. Ours did not quite do that. Yeah, we'll get to that. But that actually, the other thing I asked you to do was this sketch with a couple little things I'll tell you, and then a few sources of error. So obviously that wind is a source of error. Anyway, so what do you need to label over here? This is how you're labeling this. It's actually a very easy thing. You can label it underneath. You can label it on the diagram. The things I want are the acceleration, approximately. The acceleration. We can, to make our lives easy, what should we call the acceleration? Easier. -10. 10 meters per second squared down. That's it. Easy. Make the acceleration 10. The reason this is nice is because watch what we can do. You must have your total time. I'm going to put a box here. The only piece of data you recorded was T total. That's it. I'll make up a number here. This is probably none of your numbers. I'm going to call it 5.0 seconds. So maybe it was you. With these 2 pieces of information alone, we can get darn near everything about this trajectory. Watch this, and this is all I want you to do. And I want you to think it as you do it because it's nice to have some comfort. The total time is 5 seconds. Okay, what else do you know straight away?
VR is 0.
No.
VF is 0.
The problem doesn't start until the launch happens. So total time 5 seconds. What do you know straight away?
Peak is at 2. Peak is 2.5.
Okay, so you come up here. T peak. 2.5 seconds. Easy. What's that? Where? Where is it 0? At the, so you can come down here. You can write it down here. You can write it underneath. I don't care. The end, 0 meters. All right. What else do we know? What's that? Yeah, you could have the V at the peak is 0. Now, there's another number that you can very easily know, which I'm hoping is the one you say, based on this.
I was gonna put a problem. Didn't we launch it off of like a platform?
Don't worry about that. The truth is, put that in your source of error.
Okay.
But the reality is sources of uncertainty, they're ranked. So if you think about which ones will have more of an impact on my result, will the centimeters that you're off there and the displacement, will that affect, let's say, will that be more overwhelming or will the inaccuracy from timing with your thumb? You know what I mean? So that's like you focus on the more important ones first. That one's legit. You can put it. But that's not priority 1. Yes, Ab? I like where you're going. What's the VI? This is so great that you can just look and get the VI. Connell, what you doing? What's the VI? No, it took 2.5 seconds to get to the peak.
25. Oh, the VI is 2.5.
Close.
25.
It changes by 10 each second. The VI is 25. VI is 25. VF is -25. That's it. Yes?
Are you a blinking light diagram for each section?
Yeah, do it for the others too. What you could do, actually, which would really be nice, is knowing that the medium goes higher than the low, you should stretch yours out a little more. Which, by the way, is not hard to do. Do the same number of blinks, except start here. And then instead of ending here, go up a little higher, end here. And then split your differences. You know what I mean? There's one other piece of information here that I would like you to have. It's a good one. Actually, maybe two. One other piece of information. This is the only one that's a little bit harder. Not a lot of bit harder. It's the only one that would require a calculator, perhaps. DP. DP. How would you get that? Now, the real way, I'm going to write it down here in black, right? D is VIT plus 1/2 AT squared. But I'm going to show you a shortcut way to do this that'll make your life easier, right? If we take advantage of the symmetry of free fall and we do the way down, if we do the way down, D equals, what's the VI if we do only the way down? At the peak, we said V was 0. So the VIT goes away, plus 1/2, acceleration we're calling 10, and it's times squared. What does this become? V equals half of 10, 5t squared. But that t is only the way down. So a quick way to do the peak height is just 5 times that half time down. You could do it the full way if you want, but I'd rather you do this quickly. So this D peak is really just 5 times 2.5 squared. What's 2.5 squared? You guys know 25 squared? No, you should know 25 squared. 625. So 2.5 squared is 62.5, right? No, 6.25, sorry. Move 2 decimal places, right? Each one carries 1. 6.25. What's 5 times 6.25? It's about 31. 31 and change. D peak's 31. Cool. That's it. Here, these two should be easy too. V bar total and delta V total. What are they? What's the total average velocity for the whole thing? Average velocity for the whole thing? 0! Because the displacement is 0. That was one of your quiz questions. No, that wasn't. This was. Displacement was. Change in velocity. That was one of your quiz questions. What? 50? Yeah. VF minus VI. So you could say negative 50. All right. That's it. So you're reproducing that 3 or 4 times. Actually, 2 or 3 times at this point. Easy enough?
Or one or more.
Got it?
I think we only have 2. We only have 2. Because our third one went on the roof.
Well, borrow somebody else's high time.
No, it's a lot less.
Borrow somebody else's. Later. All right, so everybody know what to do over here?
Yeah.
And then 3 sources of error. What's up, man?
What does the V say next to log? What does that say?
Here? D end,
Right below that.
average V total, so for the whole thing. And then delta V total for the whole thing. Got it? Good. What?
So the accelerations being negative, are these all going to be positive going up? Or should they be?
What's that?
Should these be positive going up? Like, so
You could do it. Honestly, I don't particularly care about that, truthfully. I just want you to get the numbers quickly. That's what I really want you to get out of this. Like, oh, it took 10 seconds. That's 5 to the peak. That means 50 on the way up, 50 when it gets down. That's really it. And then just remind yourself, D at the bottom, 0. Average V is 0 because D is 0. Change in V is VF minus VI is 100. And then the only one that requires a little calculation is that D peak. 5 times the half time squared. That's all. So these are things you could do truly without a calculator. So this is in baseball. You go to a baseball game, somebody pops up the ball. If you could time it, you can basically figure out everything else. You can figure out how high it went, how fast it came off the bat. Is there air resistance? Yes, but this gives you a rough approximation. So, even in football, a punter kicks the ball. Time it. Sometimes they give the hang time that roughly tells you its vertical velocity on the launch. It tells you how high it went. So there's a lot of information you get very quickly just from knowing the total time, which you all are able to do since you have stopwatches on your phones at all times. Good. All right, enough of that business right there. All right. What's that?
You doing it now?
What do you want to do?
Or are we doing it